All right, so now we move into lesson 6 of exponents, and it's evaluating expressions and using BEDMAS. So let's consider example 1 here. They say simplify using exponent laws. And so what they do in this example is they say, if I give you this expression, well, anything raised to the second power can be written out 2 times as follows. Now, using product rule, what we would say is an x times an x will give us x1 plus 1, which is 2, and y times y is y1 plus 1. That's going to give me y2. The other way we could think about this is instead of expanding it out twice like this, we could use the idea that we have power rule here. So off to the side, I'm going to say this is equal to, well, by power rule, we know that the power on x and y are both 1 if they're not written. And we can distribute this 2 to both of those, meaning I have x squared and y squared. So if I wanted to use power rule, I could do that, or I could use product rule, but I would first have to expand this out, knowing the squared means to do the following. Now, in our problems today, what we're going to face is something where they say, evaluate given that we have a specific x value and a specific y value, or values for our variables. So once we have a simplified expression, we take our simplified expression, take our values that were given, and plug them in, simplify, and get a solution. So in this case, they take an x of -2, they sub it in with brackets in for x, and they take a y equals -1 and sub it in brackets for y. When you simplify, you get the following. All right, now we look at example 2 here. So, and before we go into example 2, I just want to make sure that this note is very apparent. We always want to apply our brackets when doing substitution. The reason is we want to be really careful of when there's signs involved, the negatives versus positive. When is it negative and positive? It's going to be really important to include our brackets here. So let's go on to example 2. Simplify using exponent laws. What we cannot say, we definitely cannot say, is that this means by power rule, we apply our 2 and our 2 here. That is not true. Why is that not true? Because this actually equals the expansion. So I can actually expand this of x plus y and x plus y. Now, let's actually expand this and show what it's equal to and show that it's not just simply x squared and y squared. If I expand this, I'm going to go x times the x times y. This is going to give me x squared plus xy. I then expand my y times x and y times y. This will give me plus another xy and plus y squared. When I simplify what I can, I'm going to add my 2 xy's together, and then I have y squared. We see by expansion, the squared, when anything is being added or subtracted, is going to give us something like this, not just simply this. If we apply the square in to both terms, we're actually missing this middle term here. And the same goes for, what if I was to put x minus y squared? Well, the same thing would apply. It's not fair to say x squared minus y squared. That is definitely not reasonable in this case. We know that we have to actually FOIL this out, or we have to just realize that we can't just apply the power here. Now, they take down our example here. So they say, what if we evaluate for when x is equal to -2 and y equals -1? So very similar to our first problem. Well, we realize, okay, we're going to take our x value, put it in brackets inside here, and we're going to take our y minus 1 and we're going to put it in for the y value, and then we're going to simplify on the interior here. Now, I want to really highlight this from above. The expression where we have something being added or subtracted within brackets, like this one here, 2 things being added or subtracted by power, or in the brackets with a power on the outside, they simply cannot be simplified using exponent laws. So we can't just do our squared. Like we said before, we actually would get some term like this if we expand it out properly. So let's actually look at example 3 here and see if we can piece this together. So for example 3, if possible, simplify. This is always our first step, is to say, let's make everything in terms of positive exponents and simplify our variables as much as possible. So I'm going to take this function here, or this specific equation that we're given, and say, okay, I have x to the 4, y to the negative 2 to the negative 1. We know this negative is going to cause our base value to flip. So if I have a negative in the exponent, everything in this base value needs to flip, meaning my new expression is 1 over, I have x4, y to the power of negative 2, all to the power of positive 1 now, and I have x minus y, all squared. I don't need to move things that already have a positive on them. Now, I would realize that anything to the power of 1 is just itself, so my actual expression is going to become x to the 4, y to the negative 2, and then x minus y squared. But remember, we want to write everything in terms of positive exponents. So what I'm going to do is I'm going to say this is equal to, and I'm going to move this y to the negative 2 up to the numerator instead. So I have y to the power of positive 2 over x4 x minus y squared. Now, the reason I'm going to leave this as x minus y squared is if I expand this, I'm going to get some trinomial or something with 3 different terms on it. And we don't want something with 3 terms like this. It just makes our simplification a lot harder. So if you have this plus minus case, what we're going to try and do is simplify it if we can on the interior. If it's in terms of different variables like this, we can't do any more simplification. So we're just going to leave it as such. Now, I want to take this expression and sub in for my part B, x equals 3, y equals negative 2. So for B, well, I'm going to take that expression we found on the right here that was simplified and say, okay, well, y squared, in this case, we have a negative 2 squared all over x to the power of 4, which is 3 to the power of 4, times x, which is 3, minus a negative 2, which is y, and squared. Well, if I have a negative raised to an even exponent, this is actually going to become positive, and I'll be left with 2 squared, which is equal to 4. All over, I have 3 to the 4th power is 81, and then my brackets on the interior here, I want to look at this and see what it combines to. Well, 3 minus minus, that's like adding the 2 to it. So we know a minus minus actually becomes a plus. And so we have 3 plus 2 squared, which is 5 squared. And then this is equal to 4 over 81 times 25. And you should be left with a final solution of 4 over 2025. Now this won't reduce anymore, so we know this is our final solution here. So step 1 will always be simplify using exponent laws. Once you get your simplified solution in all terms of positive exponents, we can apply all our numbers in brackets and then simplify to get us a final solution. All right, let's flip the page here. We're going to shift gears a little bit and think about what if I wanted to determine either an x value, which is a power that makes a certain number, or a base that's an unknown with a power that makes a certain number. Well, let's look at example A here. Example A says that 9 to the power of something is equal to 81. Well, if our goal is to determine the value of x, well, 9 to the power of x is equal to 81. What is 9 raised to? Well, if we raise 9 to the power of 2, this gives us 81. We look at this and we say we have a common base, meaning now all we need to do is look at our exponents to determine x. X is equal to 2. That is what makes this work. Now, in contrast, remember, if we were solving for the exponent here that makes this work, now we have a base that's an unknown. Well, what do we have to do here? We have to figure out what raised to the power of 5 gives us 32. We're going to try and rearrange 32 such that we have a number raised to the power of 5. X to the power of 5 is equal to, well, 32 can be split into 2 to the power of 5. And what I should realize here is that, like the last problem where we have a common base, this time I have a common exponent. Meaning once I have my common exponent, it's now just looking at my base and saying, oh, I have x is equal to 2. When both the exponents are 5 like this, we know that the x value is just equal to whatever's in that base spot. So x is equal to 2. For example C, we're going to kind of solve it the exact same way as we did A, where we know we're looking for a power that makes this true. So I have to make 8 in terms of a base of -2. So what will make this work? Well, -2 to the x is equal to -2 to the... In order to get an 8 here, I have to say this is to the third power. I have my common base, which is this -2. Therefore, I look in the exponent, and the exponent says x must be equal to +3. So this is x is equal to 3. And that is my solution there. Now I'm going to jump over to part D here. Part D, yet again, we're looking for an exponent that makes this true. Well, -9 raised to the x is equal to, well, we know it has to be a base of 9 or -9. What number will get us to 81? It's -9 squared. Now we see that we have this common base here. We look to the exponents in order to determine what our x was. X is equal to 2. I look at E here. E is 4 to the x. We have a 1/16. What do I need to do here? Well, I need to be thinking, how can I get something, or in this case 4 to the power of what will give me 16? Well, what I have to do is go 1 over, I know my base is going to be 4 based on what I was given here. Now I just need an exponent that when 4 is raised to a certain number, it will give me 16. In this case, it is 2. But on our left-hand side here, the 4 to the x is in the numerator. So how can I rewrite this such that my 4 is in the numerator? I can say 4 to the -2. I can bring it to the opposite spot. I can bring it from the denominator to the numerator. I need to flip my exponent sign and make this negative. Therefore, if I know 4 to the x is equal to whatever this is, well, that x is going to be equal to -2. We've found our common base. We look to the exponent, and that exponent was x is equal to -2. One more that's very similar to that. If we have x to the -2 is equal to 1/64, we know we need some number raised to the power of -2. So our goal is to find the base value, and it must be raised to a power of -2 for this to work. So I'm going to say this is equal to 1 over, well, what number raised to the power of 2 gives me 64? It's 8. 8 to the power of -2, or 8 to the power of 2 will give me 64, or 8 squared. And then if I want to move this to the numerator, I have to say 8 to the -2. I move this to the numerator by making my exponent negative, or flipping the negative. Now, what number is this? Well, we know that if we're looking at here, we needed a number raised to the power of -2. What is that number? That number is 8 here. So we look at our base values here, and we say that x is equal to 8 in order to make this work. All right, let's continue down here. So this is the check your understanding section. If you're comfortable at this point, start working on the examples. However, I think it's worthwhile to go through a couple of these just to make sure that we can reinforce this lesson here. So if I scroll down here, I'm going to take a look at, let's say C. Well, C, we want to always evaluate by bedmass, meaning brackets, exponents, and then all the other operations. So if I look at the interior here, I have -4 times 2. So I want to look at the interior. -4 times 2 is -8. And I keep this in brackets because I haven't applied an exponent yet. This is to the -3. And then if I want to write this as a fraction, well, this is equal to 1 over, and then I'm going to make my -8 in the denominator and make it a positive exponent. Now, you can evaluate what 8 to the 3 is. That would be totally fine. In this case, we should get 1 over a negative to the odd exponent will give me a negative. And then 8 cubed, well, 8 times 8 is 64 times another 8. negative 512. All right, if I go down to G here, G is equal to, well, I want to always evaluate the interior of my bracket first because we know it's going to be brackets, then exponents. So if I do this, it's 3 squared, which is 9, minus 3, all squared. This is equal to 6 squared, which is equal to 36. So that would be our answer there. Now I'm going to do a couple on the right-hand side here. What if I had one like J? Well, J is, if I evaluate the interior of the brackets, I have 3 to the negative 1, which flips my base of 3, and I subtract 1 and square it. We're not done with the interior of the brackets here. What we need to do is we need to realize we need a common denominator. So I'm going to multiply by 3 over 3, or essentially 1, but this is going to help me scale it up. This is equal to 1/3 minus 3/3, or 3 over 3, all squared. Now this is equal to negative 2 over 3, all squared. And if I square a negative, or I square this, a negative raised to an even exponent becomes positive, and this will be 2 squared, which is 4, over 3 squared, which is 9. That is our solution there. All right, I'm going to do a couple more here. I'm going to jump down to I. We want to look at the interior of the brackets here. So I have 1 minus 3. Well, 1 minus 3 in this case, and I'm going to do it off to this side here. I'm going to do it along the side here. We have 1 minus 3, which is going to be negative 2. I keep it in brackets because I haven't applied the exponent. Minus, we have a negative 4 raised to the power of 0. Anything, no matter positive or negative, raised to the 0 gives me 1. So this is minus 1 times, well, 4 squared. 4 squared is 16. So therefore, I have negative 2 to the 3rd power, which results in negative 8. Subtract 1 times 16. Therefore, I get a solution of negative 24. Now, finally, I'm going to go through M here. If I have this M question, well, first of all, I'm saying anything to the power of 0 is 1. So I have 1 times 2 to the negative 1 moves my base to the denominator, plus negative 3 minus 2 is negative 5 squared. This is equal to 1/2 plus negative 5 squared is 25. Now I need a common denominator. I'm going to multiply this by 2 over 2. Therefore, I have 1/2 plus 50 over 2. And my final solution is going to be 51 over 2. So just to be really clear here, my solution for I was here, my solution for J was here, and my solution for M is here. All right, and then I definitely think it's worthwhile to go through a couple of 2 here to help you guide your practice problems here. So simplify using exponent laws where possible, and then evaluate. So this is one of those cases where we're going to have to simplify whatever we're originally given. So in this case, we're originally given a bunch of these statements, but then they tell us what the variables are equal to. So we have to simplify and then apply these variables. Well, let's look at number 2A here. I could solve this in 2 ways. I could either apply quotient rule or move the negative from the denominator, the negative exponent. So this is going to be, if I move the negative from the denominator, I have x7 times x to the positive 2. By product rule, this is going to be x to the 9. And then therefore, if I substitute in my negative 2 to the 9th power, well, in this case, we have a negative raised to an odd exponent. That means my answer is going to be some form of negative. And then 2 to the 9th power should give me negative 512. So that would be my answer for A. For part B here, we have to evaluate using power rule. So we have a power on the outside with powers on the inside. Remember, if it's not written, our power is equal to 1. So this is equal to
we have x to the power of 1 times a 2, that's x squared. Y to the negative 3 times 2 is y to the negative 6. Now, before we make any substitutions, let's reallocate our variables in terms of all positives. This is equal to x squared over y to the power of 6. Now I can make my substitution. I'm going to substitute everything in brackets. 2 squared over negative 1 to the power of 6. Well, 2 squared we know is equal to 4. A negative raised to an even exponent will end up giving me a positive, and anything, or 1 raised to any power, no matter how large, will always equal to 1. Therefore, my solution is 4. All right, we got 2 left here. So I have 1 minus 3x squared. In this case, there's nothing we can do to simplify the interior. I can't combine 1 and this negative 3x together. So what I'm going to do is I'm going to substitute right away. So I have 1 minus 3. In brackets, I'm going to put x equals negative 3. Bracket squared. This is equal to, well, we know that 3 times 3 is equal to 9. And a negative times a negative is equal to a positive. So we can replace this with a plus, and we would say this is equal to 1 plus 9 squared. This is equal to 10 squared, and 10 squared is equal to 100. All right, last example here. We know we see this negative in the exponent. Anytime I see a negative in the exponent, I'm thinking to do the reciprocal right away. So this is going to be equal to 1 over, and now I'm going to put everything in my base in brackets to the third power. And I could write these squares on the outside and put a positive 1. However, anything to the positive 1 is just itself. So maybe I'll leave it there for just that step, but then remove it in the next. Now, by substitution, I have 1 over, and now in brackets, I have negative 1 times. Actually, you know what we should do? We should even distribute using power rule. So I have a 3 on the outside, and I want to distribute it to both of the variables. That means this is going to be equal to 1 over x cubed, y cubed. Once I've distributed this, I have 1 over, and now I need to substitute in brackets, negative 1 cubed, negative 2 cubed for y. So I go, this is equal to 1 over a negative raised to an odd exponent. In this case, a negative is raised to an odd exponent in both of the cases. If this is true, then I know that I'm going to have a negative in the end. So it's going to be negative, and 1 cubed is 1 times negative, or 2 cubed is 8 with the negative. And this is equal to 1 over, well, a negative times a negative, or negative 1 times negative 8 gives me a positive 8. All right, hopefully that helps with you doing some more practice problems. Make sure you're attempting some extra practice problems. Go through the ones that we didn't do here. Hopefully this gives you a little bit of guidance.